In this video, we will show a feature that is available when performing moving load analysis in S-frame, the influence lines. Influence lines, as the one you can see in the image showing, is a graph that can help designers easily predict the maximum value of longitudinal stress, shear, bending moment, or other effect along the structural member due to a variety of moving load patterns, as a function of the position of that load. Influence lines are important in designing beams and trusses used in bridges, crane rails, conveyor belts, floor girders, and other structures where loads will move along their span. The influence lines show where a load will create the maximum effect for any of the functions studied. For this example, I'm going to work with an analytical model, meaning that members are defined by only two nodes, and without any nodes in between. Let's check some of the properties of this structure. We have an section defined, square box section. Also check the supports is mostly fixed, but I'm allowing some rotation in the 3 degrees of freedom. Now let's take a look at the loads I have defined. If we move to the loads window and check the load status, you'll notice I defined two load cases, both load type moving load case for load case 1, and for load case 2, influence line case. If I display the member numbers, you can see I have continuous numbers from 1 to 4, then from 20 to 22, and then from 8 to 10. And this is very important, so please bear this information in mind. Let's see the load I defined for my first load case. If I right click in the moving load tool, you notice I have defined this pattern, this load pattern, and I'm going from member 1 to 4, then from 20 to 22, and finally from 8 to 10. And the increments are every 0.1 meters. Of course, my load is applied in the global negative z direction. If we move to the next load case, the influence line load, and I right click here to see the properties I define, is basically the same in terms of how the load is moving, but the load pattern is just a unitary load applied in the global negative z direction, and the increment is the same. I will proceed and run a moving load static analysis. I go to Analyze, select Linear Static Moving Load, and click OK. And it's going to create all these load cases. Once I'm in the graphical results window, I can start checking some of the results. You will notice that S-frame has different steps for each case. So remember, case 1 is our moving load case, and case 2 is our influence line load case, where I define my unitary load. So we have all these steps for case 1 and then case 2. So let's start by taking a look at the case 1, and you can better see if you displayed your loads. So you see how every 0.1 meters is advancing. Of course, you can check the results such as moment diagrams. You can see how it changes with each step. Then the other load comes into action. Remember the pattern I defined. You can also check your shear, how it changes with each step, axial if applies. But let's focus now on how to check the influence lines. For that case, I will need to go to case number 2. Here it is, at 283. So remember to select the influence line diagrams, and then you can start clicking the different points where the influence line is showing the magnitude of the moment at that location. So for example, if I click here, you will see that this is the magnitude of the moment at this location where I clicked, due to the unit load that is moving along this length. This means that the magnitude of the moment when I click at this location, it shows how's the influence on this member. Remember, these are separate members. Then if you analyze a bridge, you could see the influence line of different values. So for example, if let's take a look at the set shear. If I click at this point, let's say you have shears at different locations, and once you select the one point, you can see how the unit load is influencing at this location. So you could multiply that value that you have times the magnitude of the influence line at these points. It could be right here or there. More information can also be found in the help system. If you go to help contents, you could use the search tab, type influence lines, and then select the relevant topic. And here you can see more information about this tool. Thank you for watching, and for more tutorials and videos, please subscribe to our YouTube channel.